This is David Spears, Civil Engineering Instructor at Texas Tech University. We're talking about CE 2301 statics. This first problem is an analysis of a truss using the method of joints. We've got a simple 5-member truss with a pin up here and a roller down here at D, pin at A, supporting it's kind of cantilevered off the wall. Gotta remember that the method of joints involves first solving for the reactions on the truss, just treating the whole truss as a rigid body. That's what I've done up here first. Generally want to take a sum of moments equation about one of the supports to eliminate as many unknowns as possible. Sum of moments about point A eliminates those that AY and AX reaction that I've replaced at that pin. So if the sum of moments is about A is 0, I have these two external forces, 2 kilonewtons and 1 kilonewton at 3 meters and 3 meters. And then I have my reaction dx, which I've assumed to the left at 3 meters. So I do all the math and I get that the reaction at D is equal to 3 kilonewtons to the left. Then I do a sum of forces in the x, that's equal to 0. One thing I've got in the x is this 2 kilonewton applied force minus dx, which is 3, minus ay, because I've assumed it to the left. So ax, I should have said ax. Anyway, ax is equal to negative 1 kilonewton, meaning it's the opposite of what I assumed, and so it's really to the right. You need to take that into account as I do other calculations on here. Finally, do sum of forces in the y. It's this 1 kilonewton here down, and the AY reaction assumed up, so that works out to be correct. 1 kilonewton, and it is up. Okay, the second part of the method of joints is to find a member with 2 unknowns, and we've kind of done that for you by directing you to solve for the force in member AB. Well, so I want to go to joint B and draw a free body diagram, and I've got member AB, FAB, which I represented this vector here, member FBC, or the force in member in BC, straight down, and my applied 2 kilonewton force. I do look at the geometry of member AB. It's going over 3 and up 3, so it's really a 1-to-1. Square root of 2 is the hypotenuse. Do sum of forces in the x. Remember, in the method of joints, all I have is sum of forces in x and y. I can't use any moment equations. So here's the numbers, 2 plus, because I've assumed FAB to the right, 1 over the square root of 2 times the force in FAB is the x component of it. FAB, just rearranging that equation, works out to be negative 2 times square root of 2 over 1, which is negative 2.83 kilonewtons. The negative sign means it's compression. So I need to reverse my arrow, which I'm going to do down here on part 2. I'm trying to determine the force in the BC. So note how I've reversed that arrow. Instead of pulling away from the joint B, it's pushing at. So here's really joint B just redrawn. And I want to do sum of forces in the Y now. Positive is up. That's negative FBC, the unknown, minus, because it's also going down, the Y component of FAB, which is 2.83, which is 1 over the square root of 2 times that. So I rearrange and solve for FBC is equal to negative 2 kilonewtons, also compression. So if I use that again, which I think I do use it down here in a check, I'm going to remember it's negative 2 or compression. Next, third part was force in CD, which is this member right here. I want to look at I could look at the joint at C, but there's too much going on there. This is a simpler joint, Both of them have two unknowns at this point because I know the force in BC, but I'd rather look at the simpler case at joint D. Free body diagram, the unknowns AD and CD assumed away or pulling in tension. Have my support reaction, 3 kilonewtons from dx from this calculation up here. Sum of forces in the x is equal to 0 is equal to negative. The x component of CD is 1 over the square root of 2. And it's negative because it's to the left. Minus 3 because this is to the left. Rearranging FCD is equal to negative 3 times the square root of 2, or negative 4.424 kilonewtons, mean it's in compression. Finally, I wanted to know the force in AD, this vertical member connects the two supports. I'm still looking at that free body diagram at D. Note how I have reversed the force in CD because it's compression, so it's pushing on the joint. I have the unknown FAD. Sum of forces in the Y is equal to 0 is equal to the force in FCD, 4.24. It's up, so it's positive, and it is 1 over the square root of 2. That's the vertical component of it. Plus FAD, also assume positive up. Rearranging FAD is equal to negative 3 kilonewtons. Also, it's in compression. Now, one of the nice things about the method of joints is that I get around to the end and I can check my results. Well, I never did solve for the forces in member AC. So first let's do that by looking at joint C. This was not on the test, but it was me and I was trying to make sure I got my answers correct. I can use this check. Free body diagram at C. Remember, the geometry of member AC is it's going up 6 and over 3, so it's a 2-to-1 slope. Hypotenuse is the square root of 5. I do all the math. I put my known forces, which are all compression up to this point, 2 and 4.24 on the joint at C. And I'm just lucky because I didn't put my 1 kilonewton force on there. But I used the sum of forces in the x direction to solve for this force, and the 1 kilonewton that should have been written right there is not on there, so got lucky. FAC times the square root of 5, the vertical component of FAC, the horizontal component, x component, 1 over the square root of 5, minus 4.24, which is the force from FCD, square root of 2, rearrange, I get that force in FAC is 6.708 kilonewtons. Finally, I can go to joint A, the other end of AC, member AC, put all those known forces on there. I know everything, there's no unknowns to solve for. I can just sum for the forces in the X direction. Is all these numbers, 2.83 divided by the square root of 2 from this component, 6.708. Force in this member times the horizontal component, 1 over the square root of 5, plus the reaction at AX, 1. So I get 2 minus 3 plus 1 is equal to 0. So that checks forces in the X direction. Similarly, I can check forces in the Y direction by this equation, 2.83, 1 over the square root of 2, minus 6.708 because it's down, 2 over the square root of 5, which is the vertical component of that, plus 1, the reaction, plus 3, the compressive force for member AD from right here, negative 3 or compression. 2 minus 6 plus 1 plus 3 is equal to 0, so that checks out.